Yeah, let's go for it. Um, we can start with some quick intros, and then Ryan, I'll let you take it away for these other slides. I can go first real quick. So I'm
Sure.
Andy. I'm a product manager at Onehouse. I've been here a little bit over a year, close to a year and a half now, helping build the Universal Data Lakehouse. And in this role, I've had a chance to work with plenty of different customers, adopting open source technologies, to power their analytics. So it's been a really cool experience getting to work with a wide variety of companies and users here.
And I'm Ryan Garrett. I'm on the product marketing team here. I've been here for about half a year, but have lived in the data stack at one place or another for about the last decade and a half. So really excited to see this next evolution. It's really sort of a paradigm shift here with what we're doing with the Universal Data Lakehouse. So look forward to talking with you all about that and specifically how that applies to end-to-end change data capture today.
Sweet. All right, Ryan, you can take it away.
Cool. So before we go deep into change data capture, I just wanted to talk a little bit about what is Onehouse. Might be new to some of you. So Onehouse, we're building the Universal Data Lakehouse. You can see we've got a world-class team of data practitioners from a number of companies. Uber, our technology was originally created there. AWS, Confluent, Databricks, and more. Backed by Greylock in addition to well-recognized VCs. And we're also getting a lot of industry recognition. So you've seen the information listed us as most promising startups. We've had a couple more awards recently. And then a little bit about our platform. So what we're building with the Lakehouse is it's meant to be fast. So we're letting you work with up to the minute fresh data, cost efficient. So running ingestion, ETL, CDC pipelines, we're trying to do that at least 10x cheaper. There's definitely some metrics that show a lot higher than that, some benchmarks that we've run compared to warehouses and some of the other lake houses that are out there. Easy. We tried to make everything as simple as possible. So this is a fully managed service. You don't have to think about managing your servers and scaling and compaction and all those sorts of things that you would normally have to do to make your data lakehouse efficient. And then universal. So you're storing this in open formats. We're connecting to just a number of different sources that you work with every day, and then making your data available to just probably the broadest range I've seen of query engines to date. You can go on to the next slide, Andy. Great. So here real quick, since this is specific to CDC, we just wanted to know what databases folks are using. So if you want to go ahead and vote here, you can see the code at the top, or you can use the QR code. And we can see with the folks on the call today, what are the operational databases that you use? We'd love to know. Do you want to switch the tabs over and we can see if this is pumping in live, Andy?
Yeah, I'll keep it here for a few moments so we can have that QR code up, and then I'll switch over and we can look at the live data coming in.
Yeah, really curious to see what folks say.
Yeah, and you can just pull out your phone, scan the QR code, and it should pop up in the browser.
Hi, John in Arizona.
Right. See it. There we go. We got some percentages here.
Yep. Oh, poor Oracle. It's pretty interesting. A lot of MySQL, Postgres, and then SQL Server and other. If anyone
I'll
wants
go
to
back
type in the
so
chat
folks can scan the barcode as well.
Yeah, if anyone wants to type into the chat what their other is, I'd be curious about that. Either on LinkedIn or Zoom, wherever you may be. Oh, Postgres jumping up ahead. Is this kind of what you expected to see, Andy?
Yeah, I'm not too surprised here. I think I've been seeing a lot of folks on Postgres recently. Of course, MySQL, SQL Server are both staples. And then a bit of Mongo here is interesting too. I guess we didn't get the Oracle crew here, but there's definitely a lot of folks on Oracle databases. And I see others pretty substantial here too. Of course, we covered just a small amount in the survey. So curious if folks want to throw in the chat what some of these other databases are that you're using. If we got any updates. Yeah, one more. More Postgres.
Still no Oracle.
All right.
That's good to see. I think we're going to actually show some Postgres CDC later. Is that right, Andy?
Yeah, we will show a Postgres example for change data capture.
Cool. And so here we just pulled some quick stats from dbengines.com and wanted to highlight really sort of the purpose of CDC. Andy will get into this a lot more, but essentially there are a lot of sort of transactional operational databases that folks use, and you can see we've listed the ones that seem to be consistently the most popular here on the right. And eventually they want to be able to analyze that data. And so then we also listed what are the sort of analytical databases that they're using, the engines that they want to get that transactional data into so that they can analyze it without sort of workloads colliding, so to speak, on that transactional database. And I think with that, Andy, if you want to start, take it over and walk through sort of what the journey looks like, that would be awesome.
Yeah, absolutely. So before we dive in, I just want to talk about something that I found very useful for understanding new technologies. Moving into the analytics space, there's all these buzzwords getting thrown around, and CDC is one of those that is the most popular at the moment. So I found that it's always helpful to take a step back and look at why these technologies were created. What are the paths that someone takes that leads them to the point where they need to adopt this new technology? And that can really help you understand better whether it's a good fit for your organization and how you should be using it. So when we think about CDC, we can take a step back and think about how someone gets to the point where they want to use CDC or change data capture. We'll just use CDC for short. So imagine a company that we can say a social media company that is just being founded. Well, when they start that company, they're going to pick up a transactional database to store all of that data. It might be something like Postgres, MySQL, even Oracle or MongoDB, where they can store data that they need to power the application. Imagine you have an application that loads social media posts. When they open that app, when someone opens the app, you'll have to load post by post. You'll have a database that stores the description, a pointer to some image if there's images in the post. It'll store information about who made the post so that you can display it in the app itself. And it works, a transactional database like the ones we mentioned works really well for those operational workloads. Now, as the company grows, you might get to thousands, millions, or if you're lucky one day, billions of users. And you'll want to run analytics on that, on all of those users and the data that you have. For example, you might want to build a recommendation model to improve the posts that you're showing in the feed. Or you might want to analyze markets where your app is super popular, gets the most engagement so that you can start to sell that to advertisers and build some revenue for the application. So what we've seen often is many people start on a transactional database to run their analytics. For example, we can just pick on Postgres, you'll run analytics on Postgres, but as you hit some scale, companies will undoubtedly run into challenges handling that scale. They'll run into cost challenges and they'll run into speed challenges when they're trying to run analytics on a transactional database. Eventually, they'll realize they need to adopt an analytical database, which is just a data warehouse or a data lakehouse, which is more suited to power the analytics. And this is the path that we see a lot of folks taking. So an important question is, why do you need a data warehouse or a data lakehouse for your analytics? And here we can just look at a variety of different factors that go into this. So on the left side here, we see what it's like to run analytics on a transactional database, such as Postgres, again, MySQL, Mongo, or what it's like on the right side to run analytics on a data warehouse or a data lakehouse. If we look at each of these dimensions, we can get a better understanding of why you need a specialized analytics database to run analytics. So first, with optimal workloads. A transactional database is great for handling small amounts of data, especially key-based data where you're doing point lookups on certain rows, and handling kind of small amounts of data with high throughput and concurrency. Imagine if you have millions of users accessing an app at the same time, you're going to have a lot of concurrent requests on that database, and that's actually what it's well fit for. Both analytics, it's a little bit different. In analytics, you're scanning large amounts of data, and it's probably lower throughput where you don't need it to load necessarily in sub-second or very low milliseconds. And you probably have a smaller concurrency requirement because the number of data analysts in the company is going to be much lower than the number of users using the app. And even for some of those automated processes, analytics doesn't necessarily need to be the same speed as a transactional database. When you're looking at query performance, though, it's also important to look at the type of workloads you're running. So with transactional database, they store the data in row-based storage. They call it OLTP for online transaction processing. And it's not optimized for analytical workloads. The warehouse and the lakehouse were introduced with columnar storage that enables fast analytical queries like aggregations. And really what this just means is the transactional database works really well and is efficient and fast if you're looking up specific records like a post ID, and then you want to load the information for the post to show that on the screen. Whereas an analytical workload, you might be looking across millions or billions of posts, and you want to just aggregate, with this filter, what was the sum of all the engagement on that post or on that type of post. So that's where these workloads are a bit different, and you want a specialized system for handling that. Stability is important too. With a transactional database, you want to make sure that the database can handle that kind of P0 requirement, which is serving your operational use case and serving that production application. And you don't want to throw a bunch of analytics queries on it that may bring down production applications. By using a separate analytical database, you can actually isolate those workloads from the production database for better stability. Now, folks will try different approaches like read replicas here for the transactional database, and those can help, but at the end of the day, you want to have a different system to isolate these queries. Scalability is important too. Transactional database isn't designed to handle the large scale of data that you see when you're running analytics at scale. So for example, picking on AWS here, an RDS Postgres instance maxes out at 64 terabytes, whereas we've worked with customers here at Onehouse and in the open source community who deal with many more terabytes, petabytes, and even exabytes of data that they're analyzing. Imagine like all this historical data that accumulates over time that you want to use to build a prediction model. So in that case, you're going to go well beyond the scale of a Postgres instance. And then, of course, flexibility for use cases. We know that only strongly typed data is stored in a transactional database. So it's not as ideal for running federated analytics across many different types of sources or machine learning versus when you have a warehouse or lakehouse, you can join that structured data with semi-structured event streams. Or in the case of a lakehouse, even since it's on file storage, you can join it with unstructured data like images. And this gives you a lot more flexibility to run some of those emerging AI use cases. All right, so we covered a lot of information here about why transactional database and analytical databases kind of have their different use cases here. So what should a company do when they want to run analytics at scale? This is where change data capture, CDC, comes in, which most of you probably came here to learn more about. And really, it's the simple method of replicating your transactional database into an analytical database. So in this case, I show a transactional database here. We have our data warehouse or data lakehouse. And what change data capture does is it helps us replicate the transactional database into the warehouse or lakehouse for analytics. There's a few different approaches for CDC. One is trigger-based. So the database designer can add a trigger for those changes. There's query-based, where you search for all the rows since a certain date. And then there's log-based, which has become the state of the art here, where we read transaction logs such as inserts, updates, and deletes, and then incrementally update that downstream analytics system. So Logbase has become super popular in the industry, and Debezium is a very popular open source technology that enables that. It's also important to note that as we're ingesting all of these changes into a warehouse or lakehouse, you want to have a system that can process the data incrementally. And it's important for data freshness because you want to make sure that the analytical system is as close to consistent with that transactional system as possible. So you don't want a lot of latency where you have kind of two separate states at the same time. That's why at Onehouse, we work closely with Apache Hudi, which is designed specifically for this use case and for processing data incrementally. All right. And I'll just share a quick overview of what happens here with the Debezium example. So with Debezium, you have a change stream. So every time you have inserts, updates, or deletes to that transactional database, it'll stream those changes as messages into Apache Kafka, which is a messaging system. And then the lakehouse of the warehouse can then ingest those events and update accordingly. So next, I want to give an example of a company using CDC at massive scale. Notion is a very popular everything tool now. They do documents, they do task management, and it's become like kind of the central nervous system for a lot of companies. They have massive scale of data. So they've kind of gone on this whole journey that we saw before. Originally, they started with a single Postgres instance, and then they needed more scale, so they moved to sharded Postgres. Then they tried using read replicas and ran into some delays and some row-based limitations. And then eventually they started using CDC and bringing data into the data warehouse for analytics. Their first approach was to use a data warehouse and kind of batch move some data with Fivetran to ingest that data into Snowflake for analytics. They ran into a bunch of issues here, though, with latency, especially with costs, and in cases with some of the resiliency. So eventually they decided to move to a more open source system that was based around the data lakehouse and streaming. So they brought in Debezium to capture those change events. They ingested that data into Apache Hudi, which served as their lakehouse. And then from there, they could use Snowflake for analytics and use Spark and Pinecone for building AI. Doing this, they were able to save over $1 million a year, reduce latency, better handle spiky workloads by processing data incrementally with Apache Hudi. And it also unlocks those AI use cases because of the lake's ability to handle unstructured data.
So they've really took advantage of the universal characteristics of the lakehouse then, is that right?
Absolutely. So we see here, you can bring it into the lakehouse and then bring it out for any of these different use cases, from the Snowflake business intelligence to AI on Spark.
It's very cool.
Absolutely. So we've talked a lot about now why CDC, what is CDC, but let's go deeper into what are the challenges folks face when they're doing operating CDC pipelines on their own. At Onehouse, we've had a chance to work with a lot of folks who've, had gone through the challenges of building these. So we've seen it. We've also built a lot of these pipelines firsthand in previous roles. So we've seen some common patterns here with deploying CDC. So a few that we have here are deploying and managing event streams. When you introduce more systems like Kafka and you have a Debezium connector through Kafka that connects to your database, introducing and managing these systems also requires ongoing engineering effort and on-call handling. So this is something that adds some work to your team when you're trying to manage an extra system. We have data consistency issues. So you need to handle missing rows. You need to make sure that data is consistent between the source database and the analytics system. So that's something that you'll constantly need to be monitoring. There's checkpointing streams and restarting those CDC Debezium connectors when you find issues. Another piece is incrementally writing change data instead of doing batch rewrites, which are expensive and kind of slow down that whole ingestion process. So that is really around, going and figuring out what are the right technology choices. What do I want to use for my data integration tool? What do I want to use for the data lakehouse or the data warehouse? So this is something that involves some extra work up front. Then we have scaling the compute to actually write to the analytical database. whether that's the compute for writing into Snowflake, for example, or running Spark compute to write to a lake, or running Flink. All of those jobs require, work to make sure that they're scaling and they're operating, within your budget. Then you have to handle schema evolution. So you want to make sure your downstream system can handle if someone, who's working on the Postgres database, for instance, goes and changes the type of a column or the name, or adds a new column. All of these schema evolution cases you want to handle. And if they lead to data quality issues, you want to make sure that you're able to handle those and you don't break your analytics, but at the same time that, you're not losing data and you're not losing changes that happen. There's also, of course, transforming data for analytics, making sure that it gets into the right formats that you need for your downstream use cases, like business intelligence for loading dashboards faster. And then, of course, handling late arriving data when you're dealing with event streams. This is always possible in distributed systems. So you want to make sure that late arriving messages from database changes aren't kind of screwing up your analytics system or putting it in a state where it's inconsistent. So all of these headaches are things that people have had to deal with for many years. And that's why at Onehouse, we have been focused on building a system around CDC as one of our core sources for the Lakehouse. So I want to talk about something that we built at Onehouse to make this whole system much easier, and then we'll get into a live demo. So Ryan mentioned that Onehouse is a fully managed universal data lakehouse. And one of the key components of that is that we will do fully managed ingestion into the lakehouse. So if you wanted to do CDC into the lakehouse, we make that dead simple. You start with your transactional database. I've got some examples here like Postgres and MySQL. And what you can do is you can connect directly to that database, just provide creds. And then Onehouse will spin up the Debezium connector, run Kafka clusters, all within your cloud account. I have AWS here, but you could be on Google Cloud or Azure. And we'll run all of those within your account. We'll handle schemas, schema evolution, and all of the good stuff that people kind of had to build manually for so many years. We'll handle scaling those jobs and then ingesting them into data lakehouse tables. We write the data in all three major lakehouse formats. So you get Apache Hudi, Delta Lake, and Iceberg. And that makes that data interoperable. So you can go and query it anywhere. You can bring Snowflake to query those Iceberg tables in place, or Databricks to query Delta Lake, or even bring another warehouse like Redshift, or bring Amazon Athena and query on Hudi. So this allows you to really manage just one CDC pipeline, which reduces the data duplication for when you do CDC directly into multiple of these downstream analytic systems, because these can all just query directly from the lakehouse. And that's why we call it universal. This saves a lot of cost and also operational overhead of managing consistency across multiple copies of your data. The other key here is that we use Apache Hudi for that ingestion. So you're writing data incrementally, and this leads to super efficient and fast CDC, which I'll show in a moment. And yeah, we work with all the most popular transactional databases, and we built a system that makes it really easy to expand to new ones. So if you come in with a different database that's not in those most popular categories that we covered earlier, we can also support that. So when you abstract away all the stuff that Onehouse manages under the hood, it just looks like this. You bring in a transactional database, connect it to Onehouse, your data is securely ingested and stored and optimized, and then you can go query it anywhere in place on that lakehouse. So that's a lot of theory, but I want to show a demo now of what it looks like to actually do this using the Onehouse platform. So I'm going to show an example of Acme Retail Stores. This is a made-up company, but this data set is actually based on real data from one of the most popular retail companies in the world. What we've done here is kind of simulated a few different tables. They come from different sources just to show how Onehouse can kind of combine all these sources for you in the lakehouse. We have retail stores and items which are stored in a Postgres database, and this is where we'll do the CDC ingestion. Then we have scans. So imagine the store, every time they scan the barcode, the store pushes that to Kafka, maybe Confluent Kafka. And then we also have these categories which come from Amazon S3 just in file storage. So we can ingest from all of these sources into the Lakehouse. And Onehouse serves as that universal data platform for storing all that data. So we have our streams, databases, and cloud storage, and you can even bring in other examples like SaaS apps in here. And what we'll do is we'll manage that continuous ingestion. We'll continually optimize that data so you're getting efficient queries and also efficient writes. And we allow you to build low-code pipelines to transform that data to make it analytics ready. I touched on one table and how we store the data in those 3 separate formats. One table is the technology that allows us to do that, and it's something we've open sourced alongside Google and Microsoft pretty recently. And then of course, you can bring all of these external compute engines and catalogs to discover and query your Onehouse data. So let's go back to the slide, and I'm going to show how this works. We go into Onehouse. We'll see here, this is the Onehouse platform. We've got our data lake, stream captures, and sources. So I'll walk specifically through what it looks like to set up a CDC source. I'll go and I'll add a new source. And now we want to bring in data from Postgres. So we have Postgres CDC. All I have to do is name the source and add some credentials. I can also do it through a secret manager if I want to pass it that way. And then Onehouse can connect directly to that database, and it can actually ingest those CDC logs and merge them into a table. So once that source is added, I can go create a stream capture. And we see here that I've got this OCU limit. So this is something we offer for cost controls, where you can kind of limit the size of your clusters, the number of nodes that you're using. And then if we go here, I think I called it Acme. I've pre-created this Postgres source. And what we can do here is we can have an append-only table where we're constantly just adding records. This could be if you want to do something like slowly changing dimensions, type 2, where you don't want to delete the old records. Although I guess with SCD2, you will probably be updating one of the columns. So that's kind of just the flexibility that we let you have. So typically you'll select mutable here because we want to include updates and deletes to make our Lakehouse reflect the state of that Postgres database. And then we see here, these are all the tables that we have in Postgres. So I'll just grab one of them, this item master. And what I can do here is set up an ingestion pipeline. So we give you a few controls here. One is to quarantine invalid records, and this helps you manage data quality. So if I want, I could add validations to make sure the schema is as I expect, or the timestamps fall within a certain range. And I can also set more rules on this if I'd like. And then we can quarantine data that doesn't match those rules. So we actually write it to a dead letter queue, and it doesn't get ingested into this table, but in fact to a separate table, so you can then go back and fix any data without losing it. That's something that's really useful for handling data quality. We also have some pre-built transformations. If you want to say flatten some data, or if you want to mask a column, you can do that, and you can just set up a pipeline like this. You can also write custom transformations and put them directly into this pipeline that allows you to inject code essentially into your transformation pipeline. And then of course we have the CDC format conversion that's been pre-added because we used a Postgres source here. Now we can see here I've got my record key. That's essentially like a primary key from Postgres. So it's taken the primary key and pre-filled it in. And you could see a preview of the schema here. So you could choose a different record key if you'd like. And then we can partition, and we can use pre-combine, which is another kind of Lakehouse config that you can set. All right, I can select the data lake, and this allows us to actually organize the data in our storage, and we have a database for further organizing. And then we can sync to the catalogs. I have this default catalog set up, which I believe is for a glue catalog in AWS. And then we could also add, let's say, like a Snowflake catalog if we wanted to. So I could create this stream. I've actually got one running already because it takes a few minutes to get this set up because we're provisioning like a Debezium connector and Kafka topics in your account. So I've already preset it up. And we can see here, if we look up our Acme streams, we've got this Acme Postgres item master, but we've also got ones coming in from S3 and we've got ones coming in from Kafka. So this allows us to join data from different sources all into the lakehouse. If I look here, I can see that some data has been ingested. So I can see the records that have been captured, average commit duration over time, and I can also view logs about what's happening here. So now let's go into our query editor. And there's a good chance that I've been signed out just due to inactivity. Let's see. All right, cool. Looks like I'm still signed into AWS, so that's some good luck there. So I want to just show an example here. We have a scan summary. So essentially, we can go into AWS, go into Athena, which is managed Trino, and go join all those tables. So this allows us to run analytics at scale, and we can join data from S3, Postgres, and Kafka all in this one query and run it pretty quickly. What I want to show actually, though, is an example where we're editing data in Postgres and those changes get reflected in the lakehouse. So what I have here is I'm pulling the cheapest items from our item master list. The item master list just shows all the items that we sell in our retail stores. So I just have item ID and price here. And if I run this, I'll see the top 10 cheapest items. Right now, we see that the cheapest item is $1.04, and then 107, then 108. So what I want to do here is increase the price of each of these items because of inflation. So I'm going to stop sharing, and then I'm going to share my Postgres PG admin. All right. So now we're in Postgres, and what I'm going to do here is I have this setup that'll increase the price of the 5 cheapest items by 10%. We can see here, this is what it looked like before. And now when I run this query, we see the cheapest items are 106, 109, 110, 111. And we'll see that reflect in just a moment in our lakehouse. Okay. Let me go back to Google Chrome. And real quick, before we run this, I want to talk about the data because that'll just take a minute to update. What it does is it syncs every minute. It'll look for any changes in the database, and then it'll write those into the lakehouse. But I want to talk real quick about the data management functionality. So what we have here is the tables in the lakehouse. We can look at our retail stores, for example. And what we have here is information about this table in the lakehouse. You can see the total records, the size, size of partitions if you have partition data. And you can see stats about the data that's been written, inserts versus updates. We can also see our managed optimizations. So Onehouse will automatically manage clustering to make the queries more efficient on your table, compaction to enable efficient writes, and then cleaning, which will allow you to have some historical data in case you need to roll back the table or do some time travel. But it'll also clean up old files so you can reclaim storage. So we'll manage all of these for you and help optimize them. And then you can also manage operations like save points. So let's say you want to save kind of a point in time snapshot of the table. You can set that through Onehouse, and then you can later restore that save point if you need. And if you have quarantine set up, we can also show you stats about the data quality quarantine for records that failed those validations we talked about earlier. In this case, I don't have any records quarantined, so that's great. We also have a few more analytics if you want to dive deeper into optimizing your tables or learning more about what's going on in those tables. So now if I go back to my query editor, I'll run this cheapest items query again, and we see it was 104, 107. So we'll run it again, and now it should be 106, 109 as lowest, and there we go. So we can see here that Postgres updated, and then those updates propagated down to the data lakehouse. So we have a consistent view of all of our data to power the analytics. All right, so that is the demo. And then if I come back to our slides here, I want to talk about a few customer stories real quick, and then we'll move into Q&A in just a moment. So many customers have been using Onehouse in order to do something just like this, where they bring in data from different sources and they join them for analytics. in this first example, this is one where we helped out a lot with their CDC. So we had a large professional network, think something similar to LinkedIn, where they had a ton of transactional data sets, and their challenge was getting insights faster. They use Onehouse to do essentially what we just showed you, as well as applying some of those low-code transformations and using CDC pipelines to replicate their database into Onehouse. Once they got those tables ready in the lakehouse, they use different downstream engines to query them. So they use Amazon Athena and Snowflake to query that data in place. Another one we've seen is some batch processing where they had a couple sources streaming through Kafka and then some batch cloud storage, and they were dealing with high costs and hours-long processing. With Onehouse and just one engineer working for a couple days on this, they're able to reduce those batch processing times from hours to less than 15 minutes. So they were getting fresh data. And by reducing those processing times, they also saved close to 40% on the infrastructure costs. So moving to the lakehouse, especially with that Onehouse management and optimization, saved them both time for their engineers, data freshness, and a lot on those infrastructure costs. So efficient CDC is very key because like we saw with Notion, if you're not doing CDC efficiently, those costs can rack up. And then the last one is a talent marketplace. So they had Postgres and Mongo data that they were bringing in. They had clickstream data, which is a constant stream of events that are happening in their application that they wanted to ingest in real time. They used Confluent and Confluent's native integration with Onehouse to build these multi-stage transformation pipelines and get the data into an analytics-ready format in the lakehouse, where they brought a few different engines from BigQuery to Presto to StarRocks to handle different use cases. So I want to emphasize here that these are just a few examples, and there's so much possibility when you're using a lakehouse and when you're using a tool like Onehouse. So really what I'm interested in personally is learning about the types of use cases that people have, how they're doing CDC today and data ingestion. And even if you don't think that now is the right time to use a tool like Onehouse, I would love to chat. So feel free to add me on LinkedIn and shoot me a DM because I'm always trying to learn more and just share tips from some of our customers and folks that I've chatted with about this stuff. All right, so last slide before we move into Q&A. Because everyone here spent the time with us, we'd love to offer you a free 1-month trial account to get started with Onehouse. We are very hands-on with our trials, and we help you both with your data modeling and your infrastructure plans. So don't hesitate to get in touch with our team. You can email go-to-market gtm@onehouse.ai to get access, or you can reach out to me directly through LinkedIn or at andy@onehouse.ai. And I'm happy to chat more about your plans for CDC and the Lakehouse as well. All right, with that, let's dive into some Q&A. Ryan, you want to MC this part?
Yeah, I've got one here that came in earlier. I think you briefly touched on this, but maybe you can go into a little bit more detail. It says, does Onehouse support SCD2, slowly changing dimensions too? Can you dive into that a little bit more?
Mm-hmm. Yeah, so I touched on SCD earlier. Slowly changing dimensions are just, it's a way of modeling your CDC data. So let me see if I can pull up a graphic. Give me a sec. I've had something before that I've looked at around SCD. Okay, I think this will be helpful. So we have a few different types of slowly changing dimensions, and this is just the way of modeling the data. Type 1 is just overwriting. So this is standard. When something gets updated in the transactional database, it also gets updated in the data lakehouse or the data warehouse, whatever you're using. So Onehouse supports this out of the box, very easy. We also support type 2, which I think was the question. So the way type 2 works is it retains a full history of the values. So imagine you want to track all of the changes that have ever happened in your transactional database, but you also want to be able to see the current state of that database. What you'll do is you'll just add a new column, is active, And you can just set that to true or false in a lakehouse. And what our ingestion will do with Onehouse is we can set that column based on the incoming data. So we'll maintain all of those history of changes to the table. And then when a new record comes in, an update to a record with the same ID, we'll go back and update the old record to false for is active, and then the new record to true. So you get kind of that historical view plus the current state view. So that's something that we have customers doing with Onehouse.
Okay, so something like where you updated the price earlier if you wanted to be able to see the historic prices and whatnot.
Exactly. Yeah, it's a great point.
Got it, got it. Okay, so there was one other one came in. I think you might have answered this a little bit with the customer stories that you dived into, but it said you're a data lake house, but you're just talking about CDC. What gives?
Yeah, so we offer ingestion from many different sources. I thought CDC would be a great topic to dive into today because CDC is a challenge that a lot of folks face. And it's also an important step in the analytics journey, moving from purely transactional systems to a data lakehouse or a data warehouse. So yes, that's one of the most popular sources, but we can ingest data across other sources. We see a lot of Kafka, we see a lot of file storage, so we can bring in data from anywhere for analytics.
Got a couple more that just came in. I'm just now seeing them at least. How do you onboard to Onehouse? What does deployment look like?
Cool. Yeah, that is a great question. So I think I have a good resource in a previous slide.
Yeah.
Okay, this one. So you see here at the top, this is the customer's account. The way Onehouse works is it's deployed within your own cloud account. So it's bring your own cloud. The reason we do that is it's really great for security and for owning your data. Your data never has to leave your account, like with other integration tools like Fivetran, where you're actually bringing your data from one system into Fivetran's cloud, back into your system. It's just a security risk. So we found that the best way to do it is we can actually operate these pipelines all within your cloud account. So everything that gets deployed by Onehouse, like Debezium, Kafka, Kubernetes, is all happening within your cloud account. The way it works is you can connect your cloud account to Onehouse, and then we have a control plane which lives in our own cloud, and it doesn't need to read your data. It can just orchestrate these jobs within your account purely by looking at the metadata like table names and metadata like about what's happening with those tables. So that's how it works. In terms of onboarding, you can reach out to our team in order to get allow listed for the trial. And what you'll do is we're happy to meet with you, or we offer a self-serve onboarding if you want to just get started quick and easy. You'll link your cloud account, and then Onehouse has this UI where you can start to add sources, deploy stream captures, and those will write data to tables within your, let's say if you're on AWS, it'll write within your S3, so the data stays in your cloud storage.
Great, thanks. There's two questions here. One is, can I use Onehouse with Snowflake or Databricks?
Yes, absolutely. So I think this is a great slide for that too. And also in a previous slide, I showed how some of our customers are doing that already. So the way it works is you bring data into the lakehouse, and you can think of this as a landing layer, a landing zone for the data, where you can have a source of truth, you can have transformations that get the data into a good state. But then we've seen that I think there's a stat like 50% of Snowflake users are on Databricks and vice versa. So what you can do is you can query it in place. Snowflake, for example, released their Iceberg support recently. So if you have your Iceberg tables in Onehouse, you can go in and add those as external Iceberg tables in Snowflake and query those directly through Snowflake. The data just lives in your own file storage, but then you'll use Snowflake's compute engine for running those queries. You can do the same with Databricks, reading from the Delta Lake files that Onehouse writes.
Yeah, and I think we've actually seen internally, we haven't released any of this yet, but we've seen some pretty good benchmarking on that as well. So really excited to do a little bit of more on that and then be able to publish it.
Sweet.
And then I have some large Iceberg pipelines, but they're running slow. Can Onehouse also speed up my Iceberg data?
Yes, so that's a good question. I think we've seen a lot of benchmarks across these different table formats. And if it's important that we support all three, so that's why we use one table. But the way it works is we write data in Apache Hudi, and then we'll add the metadata for the other formats. And the reason we do this is because Apache Hudi, we found performs best, especially for these type of workloads with CDC, where you want to write data incrementally. That means you're limiting the number of rewrites to files that you're doing when data is changing. So what we found is actually, especially for update heavy workloads like CDC, it works best to use Hudi for the writes and then just add the Iceberg metadata through one table. So what I would suggest is talking to our team, and we've actually found in some cases that we can significantly reduce costs and reduce latency for that data ingestion, moving from Iceberg to something like Hudi with one table to maintain the Iceberg compatibility.
Got it. That's awesome. Here's another one that's fairly specific. I'm doing CDC with AWS DMS to S3. Could Onehouse take CDC from files in S3 to produce Onehouse tables?
Yeah, absolutely. So actually, we have a S3 source, so you can go in and add S3 here. And actually, in the example I shared where we're joining some tables, we have a stream running for some S3 data. So what that's doing is it detects, yeah, this one where it's our retail stores list. Um, it's detecting any new files that you're adding in S3, and you can actually add like a specific folder that you want to look at or a regex that you want to look at, and we'll then bring those files into a Onehouse table, automatically detect the schema, handle any schema evolution, stuff like that. So yeah, it works well with S3 or any file storage like Google Cloud Storage, for example.
Excellent. And then one last question. What's the future for one table? Is it open source?
Yeah, great question. So one table we open sourced last year. It's important that we keep this data open. And I think a lot of the challenges that we've seen customers face and our team has faced in the past is data lock-in. So the whole point of one table is that you can actually get interoperability across the whole data ecosystem while keeping your data in open source formats. So we open sourced it, and it's important that we had partners who could help us maintain that project too. So the initial supporters alongside Onehouse are Google and Microsoft, because they also are interested in this interoperability between the Lakehouse formats. So they are helping us maintain it, and the project is growing pretty quickly. I think we've got a bunch more folks who are interested in getting involved. And if you'd like to contribute or use the project, you can go search one table.
.dev, I believe.
Open source. Is it .dev?
Yeah.
Here it is. And you can see here the website, docs and blogs about it.
Yeah, very cool project. A lot of buzz around this. So excited to see where we go.
What if I already have Debezium and Kafka? All right, cool. Yeah, I mean, if you're already operating Debezium and Kafka, Onehouse works well with that too. And we have customers doing this as well. They prefer to manage that part themselves. What you can do is you can add a Kafka source in Onehouse, and then we have a transformation that can read that CDC format, those logs, and it can still write it to a table in Onehouse. So you can still get a similar experience. What we found is like if you're already operating some of those pipelines, you can keep operating them and just use the Kafka source. But the more pipelines you deploy when you want to bring on more transactional database sources, that's extra work for you. So what you can do is mix and match where for newer sources, you're using the CDC source through Onehouse that'll natively manage it for you. And then for your existing pipelines, you can just pick them up from Kafka and do the transformation.
Yeah, lots of flexibility there.
Mm-hmm. Okay, another I see, can I sync to BigQuery or ClickHouse? So yes to both. You can query through BigQuery. I think they have a good Iceberg integration, so you can do it there. And then ClickHouse also can read from any of these table formats. So this works really well if you're using the Universal Data Lakehouse architecture like we've shown here, where you ingest into the Lakehouse once and query anywhere. you can use both of those downstream engines. And then I see a question here. How do you bootstrap the target? So yeah, bootstrapping the target is part of that process. I assume you mean like you've got all of this data that's already sitting in Postgres, and then you want to first bootstrap the existing state of Postgres and then continue ingesting changes. That's something that Onehouse handles automatically. We'll just bootstrap the table, and we've built some solutions around that to make it efficient. And then after bootstrapping, we'll move to just continually ingesting changes. So that works pretty seamlessly.
Cool. Here's another one. I think we kind of touched on this earlier. Since Onehouse creates the hoodie tables first and then creates metadata for Iceberg, is it possible to create Z-order clustering for the Iceberg table?
Yes. So you'll have those hoodie stats, and then it depends on the reader itself if it's able to understand. Well, for Z-order clustering, let me take a step back. So Z-order clustering is actually co-locating data. So you can actually get benefits from the data being located closely together. In terms of actually reading some of the metadata that is unique to hoodie, that's going to depend on the engine itself. So that's something our team is happy to answer for you. I see Kyle is saying short answer is yes. So yeah, we're happy to chat about that. But yeah, the short answer is yes.
Cool. And I think that might be it, Andy. Let me see. Da, 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 da.
Oh, I see a good one here.
Okay. So are customers querying Onehouse tables as external tables, or are they copying the Onehouse tables into a Snowflake, BigQuery, etc.? Good question.
Yeah, that's a great question. So we typically will see the best savings that you're going to get, and the most optimal way to do things is to read them as external tables. So specifically with Snowflake and BigQuery, they have deep Iceberg integration, so it's great for reading it. But most of these engines have integrations with the Lakehouse formats anyways, and even warehouses can read from Lakehouses at this point. So typically reading as external tables will save you, so you don't have to run additional ETL, and that's what many of our customers are doing and are loving that. There are cases maybe where you want to bring it into one of those systems. You can absolutely do that also, where maybe you have like some pre-prepped data that's a universal layer in Onehouse, and then you want to build a few aggregate tables directly within in BigQuery. That's something that you can do if you'd like to.
I think that looks like that's it. So with that, I think we can probably go ahead and wrap it and give everyone a couple minutes back. I think, yeah, 5 minutes back. So appreciate everyone's time. That was a really, really interesting webinar, and really excited about what we're doing here and all the things that we can do by providing your operational data to your transactional data to your analytics system. So any more questions, feel free to reach out, and happy to follow up from there. Thank you all.
Thanks, everyone. And yeah, please do shoot me a DM if you want to chat more about this stuff. I'm always happy to hop on a call.